Hello and welcome back to Rockpile Tutors. Today we're going to do a bonus set of word problems following off the multiplication and division of fractions video from a few days ago. So without further ado, here we go. Okay, let's start with Allie. Allie ran 2 3/4 miles on Monday, 3 1/4 mile on Wednesday, and 4 3/4 miles on Friday. How many total miles did Allie run this week? So you can see that I'm drawing things out here. I like to doodle while I'm reading word problems. Even if it ends up not being part of the solution, it gets my mind engaged. And often as I'm drawing, I'll change the drawing as I understand more about the problem. This one is relatively straightforward. We have 3 mixed numbers and we're going to add them up. So we're going to line them up with whole numbers and fractions. And 4 3/4. Let's put our operation over here. We are adding. All right, first thing I do, check your denominator. Denominators, all fourths, so we're good. So in this case, we're going to add up all the whole numbers. 2, 5, 4 is 9, and now I'm going to add up all the fourths. 3, 4, 5, 6, 7. So the first step in this answer, the third step, the first addition step, is getting us to 9 7/4. And then we assess what do we need to do. All right, I see this fraction is an improper fraction, and I need to fix that. So what are we going to do? We are going to turn that into a mixed number. So for now, I'm going to leave my 9 alone, and I'm going to add to it a bunch of fourths. So the way to do this is how many times does 4 go into 7? And that's 1. So I'm going to turn 7/4 into 4/4 plus 3/4. And then as we all know, 4/4 can be replaced as 1, which is going to make it add to the whole number. So my final answer here is going to be 9. Let's try that again. My final answer here is going to be 10 3/4. All right. If you didn't understand that, back up the tape, watch it again. Try it yourself first, and then watch the answer. All right, we're now going to move on to number 2. 2 wooden beams sit side by side. So I'm going to just draw some wooden beams, right? Doesn't matter what the picture is, just start drawing. One is 12 15/16 wide, and the other is 8 7/8 wide. What is their combined width? Okay, so I'm looking for this total, and so as I'm assuming you recognized by now, I'm going to add those 2 fractions. So let's set that up the same way. We're going to end up with 12 15/16 plus 8 7/8. All right, what did I say the first thing we're going to do is? We're going to check our denominators. I have a 16 and an 8. That's not going to work. We need to figure out how to add them together. So I need to figure out my common denominator. And as we saw, the easiest way to do a common denominator is 8 times 16, which is going to be 80 plus 48, 128. That seems like overkill, right? I recognize that there's a lot in those numbers, so I'm going to go the other way, going up the timetables of the larger one. So I start by putting them here, and then I start with the first entry of 16. Does 8 go into 16? Yeah, it does. So that tells me my denominator is going to be 16ths. Draw them both here with a denominator of 16, and let's figure out how to get there. 16 takes times 1 to get there, so this is going to stay 15/16, which makes sense. We're doing nothing to that fraction because we like its denominator. The 8, however, in order to get to that 16ths, I need to multiply by 2, so I'm going to do the same thing to the top, and I'm going to end up with 14/16. Now, I'm in a good place to add them, so I add my whole numbers first, and I get 20. Then I add my fraction, and I get 29. I'll write it over here. 29 over 16. Same as last problem. Now I need to turn that into 20 plus 16 over 16. How many times does 16 go into 29? Once. And so it's going to be 16 plus 13 over 16. Right? Turn that into 1, add it to the whole number, and we end up with 21 and 13 sixteenths. And that is how we solve that. All right, let's do a few more here. Let's try to find some more difficult ones. Oh, they're usually no fun near the end. All right. During the first 3 weeks in November, Eugene recorded the following amounts of rainfall. So week 1, let's make this one into a little chart. Sometimes it says chart. So week 1, there were 2 and 3/4 inches. Week 2, 1 and 2/3 inches. And week 3, 2 and 7/12 inches. How much rain fell during these 3 weeks? So again, we're going to add. So I'm going to set myself up, leave plenty of space between things, and depending on what you have to do. 1 and 2/3 and 2 and 7/12. I'm adding, and let's figure out what we're doing for a denominator. So I check them. They're different, so I'm going to need a new one. So let me set myself up for that. And now I'm going to go with the multiplication again. So I want to have 3, 4, and 12. Hopefully you guys can see where this is going. My first check says 12 will work because both 3 and 4 are factors of 12. So now I can go back here, and everything I'm going to do in 12ths. So I've got some conversion. Do the easy one first. 12 times 1 is 12, so that's a 7. 3 times 4 is 12, so 2 times 4 is 8. And 4 times 3 is 12, so 3 times 3 is 9. Add up my whole numbers. 5, 9, 17, and 7 is 24 over 12. How many 12s go into 24? 2 of them. So I'm going to do 5 plus 12 over 12 plus 12 over 12 plus 0 over 12. So when I turn these into whole numbers, I end up with the answer of just a straight 7, because all of the fraction turned into 2 whole numbers, which turned into 2. Okay, a little surprising outcome there. Let's try to find some subtraction here. All right, well, let's do another confusing one first. Okay, the newspaper, number 12. The newspaper said that 400 of the town's students, high school students, already have had the chicken pox. So these are people who had chicken pox. Of this group, 3/5, so I know I'm going to be doing fractions here. So I'm going to call this 3/5. 3/5 of them were before, so I'm going to go less than 4th grade. 1/3, right? I'm just drawing these. I'm not trying to make them to scale. 1/3 were 4th, 5th, and 6th grade. And the remainder, so this covers everything from 0. This covers 4, 5, 6. And so the remaining, we're going to call that X, is greater than 6th grade, which means 7th, 8th, etc. All right, so how are we going to solve this? Well, I am going to add up the total here, and then what's left is going to be 1 minus this fraction, something over something. So let's do that. Let's add 1/3 and 3/5. All right, check my common denominator. 3, 5. 5 doesn't work. Does 10 work? No. Does 15 work? Yes, it does. So in this case, multiplying together or taking that one up says that 15 is the right answer. Let's divide these into 15ths. 3 times 5. So 1 times 5 is 15, and 5 times 3, so 3 times 3 is 9. My answer, as I add these up, is going to be 14 over 15. So that means that the pink area is 14 over 15, and 1 minus that is going to be what's left, which is 1/15. So the fraction of the group getting chicken pox after the 6th grade is 1 over 15. All right, number 13. Every time I've taught it has been a little bit difficult, so let's see what we can do here. All right, for gifts, Alexis makes serving trays. What is the length and width of the tray that she makes? And what they're showing here is a little bit like a print, a manufacturing print, that tells you everything you need to know, but it might not put it where you think you need to know it, right? And so here, I know that for a general rectangle, for the length and the width, typically this is going to be the length and this is going to be the width. So let's take a look over here. It looks like the big chunk of the length, right, going to about here and here, is 16 3/4. But then I've got this stuff. Why does that stop there? That stops there because then they're going to tell us about the handles. And I'm going to look to see where that's identified, and that's down here. So what I've got here is I've got 2 9/16 over here, and 2 9/16 over here. So to find that total length, I'm going to add those 3 up. And then similarly, we can see the same thing over here, 8 7/8 plus 2 times 1 3/16. So we'll get to that one. Let's do the length first. So for the length, I'm going to arrange them in the single digit whole numbers first. So 2 9/16, 2 9/16, and then 16 3/4. And what am I doing? I'm going to add them up. First step, I heard all of you this time say, check your denominator. I got a 16, I got a 16, I got a 4, so I don't have a denominator. Going pretty quickly, I'm going to go over here, I'm going to find myself a denominator, and guess what? The first one I check, 16 works. So these are going to be the same because I'm not changing the denominator. And this one, I know it's going to be 16, and how do I get there? Times 4, so this is 12/16. Next step, let's go whole numbers. 16, 18, 20, 20 and 9, 18, plus 12 is 28, 30, and 30 over 16. What's that get me? I see 1/16 going into 30, so I'm going to go 20 plus 16 over 16 plus what's left? 30 minus 16 is 14 over 16. Boom, you're a whole number. You go in there, and now I get 21 14/16. Now, I've fixed the improper fraction part of the fraction, but what happens here? My last check needs to be, do I need to do anything else? And it looks like that fraction can be reduced. So I'm going to take a 2 out of it and divide both sides by 2, and I'm going to get 7, and I'm going to get 8. So the final answer is going to be 21 7/8. So I'll put that up here. My length is 21 7/8. Make sense? Let's do the same thing with the width. Oops. room here. All right, let's get this out of here. Oops, didn't mean to do that. But we'll put it back. All right, so my width now is going to be 3 numbers as well. So my middle part is going to be 8 7/8. And each of the top and bottom, where's that number? 1 3/16. So you can go already into this and see that we're going to have a similar thing to do, but let's go ahead and do that. I'm going to have 2 of those. So 1 3/16 from the top, 1 3/16 from the bottom, and then 8 7/8 for the large dimension in the middle. Right. Based on our last one, we can quickly do the math and see that we're going to be in 16ths. If you don't understand that, go back a few problems and when I go through it step by step. Times 1 times 1, 3/16, 3/16. What do I got here? Times 2, 14 over 16. Add up my whole numbers. I get a 10. Add up my fractions, and I get 3/16, 6/16, 20/16. All right. How many times does 16 go into 20? 1 with 4 left over. That's going to get me to 11 4/16. And everybody should be yelling at me to reduce that fraction. So I'm going to end up with 11 and 1 over 4. All right, let's do one more. Why am I not subtracting any of these? All right, here we go. Map number 14. Here they give us the drawing, right? You'll notice that's a similar drawing that I drew. And so what we want to find the area here, because the map shows that the corner grocery, right here, is between Will's house and Lisa's house. How far does Lisa live from Will? So right now, I want to find this, okay? And that is going to be the addition of Will's walk from his house to the grocery store, and then the distance from the grocery store to Lisa's. So I'm going to add 1 9/10 plus 3 3/10. All right, by now we know how to do this. Add my whole numbers, 4, add my fraction, 12 over 10. What do I have? I got a mixed number, or sorry, I have an improper fraction. I'm going to make a mixed number. 10 goes into 12 one time. Turn that into a 1, so that's a 5. And then what's left? 2/10. Check for reduction. 5 1/5. Divide both sides by 2. So that is the first number that we need. The distance between Will and Lisa is 5 1/5. Next question, how far is the library from the corner grocery? So now what I'd like to do is I'd like to know this distance. We'll look up top. So how do I make that up? Well, it looks like it is all of the 8.5, but not the distance between corner grocery and Will's. So to take that out of 8.5, I'm going to subtract. So I'm going to do 8 1/2 minus 1 9/10. All right, so now this is the most complicated that we've seen, where we have to do all of the above. So I'm going to start with a common denominator. When I look at my common denominator, 10 will work. So I'm going to do everything in tenths. Here we go. No change there, so no change there. Times 5 there, times 5 there. Okay, now remember I'm subtracting. So my next question is, can I reduce, or can I subtract 9/10 from 5/10? And I cannot. So what does that mean? I need more tenths on the top. I'm going to take a whole number and convert it. So my 8 is going to become a 7. That 1 that I took away, I'm going to turn it into tenths, which will give me 10 over 10. I can't forget that I had 5 of them here, so I need to add it. And now I'm going to rewrite 8 1/2 as 7 15 tenths. Right? We intentionally made an improper fraction in order to serve our purposes. And now I can subtract 9 from 15. So I'm going to do that, and I'm going to get 6 tenths. And now I can do the whole numbers, and 7 minus 1 is 6. What can I do here? I can reduce. Looks like there's a 2 in there. So my final answer will be 6 and 3 tenths. All right. So I hope you enjoyed this video. I hope it helped you, and I hope you get less concerned about word problems and feel confident in your fractions. Again, Rockpile Tutors. If you're looking for individual tutoring, give me a holler.